In the last lecture, we explored how to represent the ordered pairs in a solution set graphically, the idea being a picture is worth 1,000 words. Then what we did was we looked at the solutions to an equation. So what would the solution to an equation look like? How can you visualize that? And what we did was we converted it into a set. So all the ordered pairs that make the equation true, we include in a set called the solution set. And then we can go back to the previous example and represent all the ordered pairs on the xy axis graphically. The difficulty was, for example, for an equation, there can be infinitely many ordered pairs that make that equation true. We are, or even if you use a computer, are only plotting finitely many. And that's a big problem. You could just misjudge it and not get the right ones. So we're going to look at that more. Now, we're going to move up on the food chain, and we're going to introduce functions into this environment, right? So we've talked about sets, we talked about equations, we've linked equations to sets. Now we're going to talk about a function. So what is a function? Well, for a function, I need a set, right? And I need a rule. And the rule has to have some caveats to it. For every element of the set, you can only have one value of the rule. Okay, now let's look at some simple examples and think about that. Don't look so astonished. Don't look so astonished. Okay, let's look at this. We also call the set the domain. Okay, we'll get on. It's no big deal. So think about this example. For a set, I'm going to say all students in this college algebra section. Right, everybody in the college algebra section. So if I go to my UNLV and go to the grade sheet, and I'll have all the students enrolled for the class. So all the students in my section. Okay, it's very, very precise, very well defined. And as my rule, I'm going to assign a final grade for the semester. Now notice there's only one final grade, right? I do not have the option to assign multiple grades, right? Now, is this a description of a function? And again, often functions are described verbally. Not every function is f of x equals x squared, okay? So mainly what we're going to work on, but I mean, functions are described verbally. So is this a function? Well, just check the criteria. We have a set, right? It's well defined. You can see all the students in this section. And we have a rule. Every element of the set, for every element, so for every student, you're the elements, right? For every student, I mean, don't be intimidated by the terminology. For every student, I can only have one value, and the value is the final grade. So is that a function? Yes, that's a perfectly nice function. Okay, now this is where the difficulty comes in. And again, if everything was done right, how about if I just say assign a final grade for the semester? And the question is that a function? So right, I shortcutted this a little bit. This is our difficulty. This is why we have problems. Well, notice I haven't spelled the function out, right? I haven't told you what the domain of the function is. So we have to guess. Right? I mean, this is where we're going to have problems, right? Where we're not doing math, we're guessing the intent. Am I talking about this section? Am I talking about all sections? Am I talking about the world? I mean, you just don't know. It's not said. And again, you're going to see in the problems we have that this is going to be a source of confusion. So we want to know about it. Is the function clearly stated? Okay, so that's the issue. And when you don't specify everything, maybe it's convenient, maybe it's shorter to write out, but this leads to confusion, leads to mistakes. Okay, so we're going to pursue this idea. Okay, and again, my idea is that you should be aware that this is going on. I don't roll your eyes at me. I want you to be aware this is going on so we don't get surprised. So here's the favorite example: f of x equals x squared. Is that a function? Right? Is this a function? Do you have a set? I mean, what's the set? I just gave you the definition. You have to have a rule and a set, right? What's the set? Well, the way it's set up is if again, this is what you need to know. This is how supposedly the confusion we get around that. You can say this notation says, don't be intimidated. The D stands for domain, right? Domain of the brackets are shorthand for of f, the domain of f. And it says a set of real numbers. That funny R there is set of real numbers. So if you're not familiar, that's real numbers. And again, what's a real number? 2 is a real number. Minus a half is a real number. Any decimal, finite dimension, finite decimal, or pi has infinitely many decimals. All these are real numbers, okay? So that's what we're talking about. So the domain is a set of real numbers. So by default, anything we can plug in for x and it works, we're good to go, right? And it's assumed you can do that. So that's the idea. Okay, so for the rule, do I have a rule? Well, they gave us the rule. So again, they gave us the rule, they didn't give us the set. Now, how do I interpret the rule? Well, the x in the rule has to be in the set. So this says x is an element of. This is a funny e. Again, you can't, maybe you could just use an e, I don't know. But that e-shaped symbol means is an element of. So this says x is an element of, well, the domain of f, which is the set of real numbers. So x can be any real number. In other words, that's admissible to plug into that slot for x. Now, we're going to be doing other things later on, and you should think of x as really being a placeholder. I mean, that's how I see it. X is just a notation that's easy for typing in the books, but maybe today it would be better just to have a box. The x is not a value. A value, something has to be placed into x. It can be a number. It can be another function in composition of functions, right? So you have to be careful, but you should think about it as anything can be placed into this x. It's a box, right? So x on the left, and you see we just place something in that box on the right. Okay, so it's just a placeholder. It's just a notation for a placeholder. So let's look at a few examples, and they're a bit more complicated. We're just starting with a basic one. So 2 is a real number. And that's my function, right? F of x equals x squared. So notice how I think about this. 2 just going to get placed in the box. Gets placed in the box on the left. Gets placed in the box on the right. And you're done. Squared means 2 times 2 equals 4. Right? Square means do it twice. I mean, that's straightforward. How about something like this? A plus 2. Now, see, this is where we start entering into some ambiguity. What do we mean when we say a plus 2? Well, notice a plus 2 is in the box, right? So a plus 2 is in the box. So I just plug it into the box, right? And evaluate it. The square means the quantity times the quantity and multiply it all out. And it just doesn't make anything. We'll come back and talk about it. It's just, again. So, okay, how about f of x equals x squared? So this is the notation I'm going to use. I won't say, it's certainly not my own invention. But it's not really the most standard in a college algebra book. I'm going to use it because I want to avoid the ambiguity. I want to make sure we're always comfortable with what we're talking about. You don't have to use it, but I'm always going to be clear with what we're talking about so that we don't run into these problems. What are we talking about? So notice this notation. It gives me the set, right? The domain of f is the real numbers. It gives me the rule, f of x equals x squared. And notice f. When you just write f, you're talking about the name of the function. The name means two things. It comes with the set and it comes with the rule. When I write f of x, I mean the rule. When I write f, I mean both the function and the rule. Again, I'm not going to hold your feet to the fire on this. Don't worry if you don't write it right. You're not losing a point or anything. But I'm not going to do it wrong just to do it wrong, okay? So I'll be consistent in how I use it. And I encourage you to. I mean, so f means, again, there's a set and there's a rule. Okay, that's what we mean when we write f. Two things, right? Now look, here's another example. Again, it's compare and contrast, compare and contrast. Okay, notice the name of my function is g. Okay, that's fine. Now notice the set is different. The domain here is different. I'm saying that we're only taking numbers. So this is red, domain of g equals the set, right? The brackets mean set of x. The bar means such that. It's just math shorthand, such that x is greater than or equal to 0. Again, you don't have to use this notation, okay? It's fine. But I'm a mathematician. I don't know. I want to be precise about it. But again, you don't have to panic about it. I'm just trying to keep things clear. So again, there's no question about how did I get an answer or what happened. Okay, so I have a rule. Okay, so we're good to go. And again, I interpret that rule as the x is just a placeholder. It's a box. Something has to go in that box. Okay? And notice these functions, f and g, are not equal. Now this symbol, again, don't panic about it. It just means not equal, right? In other words, a function, if you're going to use an equal sign, you have to have a number equals a number or a number does not equal a number. When I'm talking about functions, I have a rule and a set, so it's not appropriate to use the equal signs. And I'm not trying to, again, just split hairs. I'm not going to speak the language wrong. And math is a language. I don't know. Okay, so you don't have to use it. I'm just saying f and g are not equal. They're not equal as functions. Why? Notice they have the same rule. And if you only look at the rule, you say, these are the same thing. What am I missing? Well, they apply to different sets, right? Remember in the beginning when I said, am I talking about assigning a grade to everyone in my section, everyone in college algebra, or everyone in UNLV, or everyone in the world, okay? So the set matters. It's where the rule is applicable. Okay, so I have different sets, so they're different functions. They're different functions. Now we're going to play off of this a little bit, right? You're going to see, we're going to play off of how to write functions differently and so forth and so on. So that's going to be something that does come up. Yeah, you're feeling it. I can tell. We're getting there. We're getting there. Now, here's an example. We're just going to start out basic, and then we're going to build up to how we're going to use this later. Again, when I write f of x equals 2x squared minus x plus 3, I really mean the following. Again, I'm not saying you always have to write it out, but you should certainly think about it. I am saying there is a function f, right? It has the domain of all real numbers. X can be any real number. Any real number can go in that box. And I can then evaluate the rule based on any of those real numbers. So when I write only the rule, I mean everything. All real numbers. It's applicable to all real numbers. So now let's dive in and look at this a little more. F of 2, okay, we'll start off basic. Here's my rule. It's really a box. X is really a box. I'm just, whatever goes in X goes in the box. I'm just going to plug it into the box, right? All the x's are just the boxes. Now notice 2 is what x is. I just plug it in everywhere I have a box or wherever the x is. And then you just do the calculation, right? Just do the calculation. 9. Okay, I mean, that's just the beginner problem. How about this? Now see, now we're back to this other one. I want to explore this in a little more depth. Okay, what are we going to do here? Well, okay, what are we talking about? This is where the ambiguity comes from. The domain of this function is the real numbers. Whatever goes in that box is a real number, right? I mean, again, I'm not going to try to trip you up. I'm going to be straightforward. I just want you to be aware of these things. Again, it's not trick questions. I'm not going to pull teeth on the test. The tests like the homework or like the problems we do, I'll be very clear. All right, so x is any real number. And it goes in the box, right? It has to be a real number. So we have a plus 2. A plus 2 has to be a real number. 2 is a real number, so it says a is a real number. See that? They're assuming you know that. Now again, it's not going to have a big impact in the course, but we're talking about functions, so just be aware. Then why don't we just come out and say so? We just assume you do it. I mean, this is why people get frustrated. This is why you give me the angry face. This is why people get frustrated. There's a lot of conventions. There's a lot of shortcuts that you should have learned through K through 12. But, you know, most people don't, okay? I mean, this is it, but that's what we mean. Why don't we come out and say A is a real number? We probably should. Okay? I don't know. It just, you know, just makes me feel good to harass you. I don't know. I mean, I don't know. It's just okay. So that's a real number. So again, we have our function rule: x, a plus 2 is x, y, because it's in the brackets. So I'm just going to plug it into the box everywhere the box appears, right? And just drive on. And if if you worked it all out, it's whatever. It's not that important. It just comes out to this, right? It just comes out to this. I mean, the important part was a plus 2 is a real number. A is a real number. You just substitute it into the box. Okay, now here's our first one. We're going to graph a function. Now notice what we know how to do. We know how to represent a set of ordered pairs graphically, right? Draw a picture. We graphed an equation by finding ordered pairs that satisfy the equation, thereby making the solution set, and then building on what we know, representing the ordered pairs in the solution set graphically, right? So we built, right? Doing the equation built on graphing a set. Now we have a function. How are we going to graph a function? Again, that's only the rule, right? But how are we going to do this? We know how to graph an equation, right? We find the solution set. Right? We find all xy ordered pairs that make the equation true. Now in practice, we can only find a finite many. By hand, maybe 5. Right? Even on a computer calculator, only a finite number. So is there any equation sitting around? Right? Well, we're going to make one. We're going to make it into an equation. We'll say that y equals f of x. That gives us xy pairs. The y pair is associated with f, value of the function. So I'm going to make this into an equation. You see, now we just do what we know how to do from the last section, the last lecture. I have an equation, and I can pick x, y, the x values, and I pick these because I know the answer. And that's the equation, so I can just calculate the y values, right? I mean, it just builds on what we did before. And then I put them in a set. So minus 213 goes in a solution set, minus 1, 5, 0, 3, and so forth. So now I have a set. See, we're always building on what we've done. And then I can represent this set graphically, right? There's my minus 213 point, my next point, minus 1, 5, 0, 3, and the others. And I drew that red curve in there, but it is a guess. Why didn't I draw it with straight lines connecting those dots? Well, again, we don't have enough information for that yet, right? This is part of what I'm leading you up to. Why didn't I just connect those dots with straight line, with lines? Because I know the answer. You say, well, how do I know? We'll get there. Okay, now here's a more serious example. Okay, and we have to be more careful. What I like to do is a preliminary step, right? I always see it as an algorithm. There's a first step, second step, third step. This 0 is just to make sure you know what the function is, right? The domain, the range, because it's going to play a role here, right? So make sure this is where the ambiguity comes in, and we want to eliminate that, right? So there's my rule. They gave me the rule. What's the set? Now, there has to be a precise way of doing this other than guessing, okay? So how do we figure out? There's an algebra rule that applies. A over B is undefined when B is 0, right? I mean, you should understand everything we're doing in this course. I hope we never get to a point where I just say, well, take my word for it. Well, I think there's one result. Take my word for it, this is true, right? I mean, just A over B is undefined when B is 0, right? That's obvious. In our case, B is x minus 1, right? B is x minus 1. So it's undefined when B, x minus 1, is 0. x equals 1. So again, it's undefined when x equals 1. Notice our domain tells us where it is defined, right? So if it's not defined at 1, 1 can't be in the set, right? X is undefined at 1, so 1 cannot be in the domain. The domain is the x values that are acceptable, that are admissible to apply the rule to. Now again, it is a straightforward example, and you say you're making a mountain out of a molehill. I'm not saying you have to write any of that down, right? I'm not saying you have to write any of that down. What I am saying is that everything we do in this class should be math and not a guess, okay? And that's what I'm going to emphasize. There's no magic. Now look what's happening. This is going to be key here. As long as x is not equal 1, we can apply the algebra to this, right? What you presumably what they did in K through 12, right? So let's look at this. As long as I'm not talking about x is 1, and I'm not, right? The domain says x, all x is other than 1. Well, I'm going to factor the top, right? I can factor the top. And notice what I can do here. I'm going to distribute the bottom. I'm going to break it down like this, right? You see what I'm doing here? This is how you cancel. Canceling is a big problem in the course, bad algebra. Now, you're not going to lose 10 out of 10 points on a problem, well, unless you completely change the problem, right? But, okay, algebra happens. What's going to happen, reason I'm concerned about algebra mistakes, if I can digress a moment. Suppose there's 10 points on the test. You lose 2 points on the first one for a dumb algebra mistake, 2 points on the second question for a dumb algebra mistake, 2 points on the third question. You see where I'm going with this? Now you're looking at a high grade of an 80, a B minus, C plus, and you just throw away all those points for dumb algebra questions, right? So canceling is one big problem. You don't actually cancel. What you actually do is it equals 1, right? If you can't explicitly factor the terms out. And again, I'll get sloppy, we get sloppy, we take shortcuts, and this is where the danger is. But if you are having trouble with that, if you make algebra mistakes doing the homework, put in more steps and be careful. So you don't really cancel. Notice the x minus 1 over x minus 1 is 1. And 1 times anything is, so there we have it. Okay, so pay attention. I'm just warning you. Algebra mistakes take a toll. They really do in the course. Like that square root I talked about in the last lecture, that's a problem. Algebra mistakes, that's a problem, canceling things wrong. Okay, so just be aware. So notice, as long as I'm saying x does not equal 1, our rule simplifies to just x plus 3, which is certainly much easier. Okay, pros and cons, pros and cons. Again, it's not right or wrong, better or worse. When I just gave you the rule, what I really meant was the rule and the domain. You had to work out the domain, right? That's what I gave you. So that's a shorthand notation, and it means, well, all that. Now, the interesting thing is the rules are exactly the same, right? As long as we're not talking about 1, these mean exactly the same. That's why I call them both F. They're exactly the same as long as x does not equal 1, right? So what's advantages and disadvantages? Again, it's not right and wrong. What is the advantages to the different ways of specifying it? Well, if I only give you the rule x squared plus 2x minus 3 over x minus 1, I only have to write the rule. I mean, I don't know. People think that's better. I don't, but people think it's better. Or at least it makes more work for you. Now, I only give you the rule true, but the rule is more complicated than it has to be. The negative here is I have to figure out the domain. You do. And I think that's what I just think this is one of these kind of punishment things. I mean, I don't know. Why is that an advantage? It seems like this is more work. I give you only the rule. It's a complicated rule. And moreover, I have to make you do the work to figure out the domain. Okay? Now let's look here. The negative in the bottom presentation is that I have to write both the rule and the domain. The rule is easy. And you got to do the domain no matter how you cut it. Right? I mean, you're going to do the domain one way or the other. You're going to know it. And the rule is usually easier. but I have to give you the domain. So it's pro and con. I don't know. I mean, I have some ideas because it's a hazing exercise. We have to make you work for everything has to be painful. I would, at any rate, be aware that you can often simplify the rules. And why not work with the easy rule if you can? So I have my function. I understand what I'm talking about. Now, in order to graph a function, I have to turn it into an equation. So y equals f of x, and there's my equation. Nice, simple equation. Why work with something complicated? Of course, it'll be a line, but we don't know that yet. It's a simple equation. Again, the rule is easier. And again, I need to understand 1 is out of the question, right? We don't talk about 1. We just don't talk about it. All right? So let's come up with a solution set. I make my list of points, -2, -1, 0, 1, 2, right? I just drive merrily on. There's my rule, y equals x plus 3, right? Going according to plan, find my y values. Right, just plug in the x's, get the y's. Okay? Solution set. And I'm feeling good. I don't know, big mood, but I'm feeling good. Right? And it's all wrong. I mean, I led you into that. I rushed you along. Right? Why is it wrong? What on the page in red that I miss? X cannot be 1. And this is the danger. When you plot along merrily without thinking, this can be kind of problems. I can't have that point, and I can't have that in the solution set. I mean, again, they're easy things to miss. That's why you have to have a disciplined way of working out problems. So if we're going to graph it, I just put all the information on the left because I was running out of space. Here it is. I know I only plotted 4 points, but they're infinitely many. It's actually a line, and we'll talk more about this later, and it's not defined when x equals 1. Now, people represent that in a number of ways. I'm just going to do a circle with a hole in it to show that there's nothing there. I mean, there are other ways you can do it. It's fine. All right? But again, we had to guess the shape of this. Okay, so that's the graph of that function. Now, how about if I give you this function and ask you to graph it? Okay, so what happens here? Compare and contrast. Notice I gave you the rule, and I gave you a set. You say, well, that rule's good everywhere. X plus 3 is fine. I'm not telling you that. I'm telling you you can only use that rule as long as X is not 1. Right? Remember, final grade. I only distribute final grades to my section. Right? It's no use saying I can give it to everyone in the world. That's not what I have the authority to do. All right? And if you go through the process, it's exactly the same graph. They have exactly the same XY values in their solution set. So they're the same function. They're exactly the same function. And again, notice the pros and the cons of this example. In the first case, I only gave you a rule. The rule is complicated. You had to simplify. Well, I guess you didn't have to simplify it, but certainly you had to figure out the domain. And if you were to plot the points using the complicated rule, that's a bit that's tough. In the second case, right? In the second case, the rule is easy. I gave you the domain. What's not to like? I mean, I don't know. In my mind, we should always be giving you in the bottom way of writing it. I don't know. I don't know. I'm feeling huffy too about that. I don't know. Here's another example. Now notice in this case, I only gave you the rule. And it's x plus 3 like it's been for the other examples. So what's its graph look like? Well, the domain, I didn't put in all the steps, I'm just trying to make the point. The domain here, since I didn't tell you, you take all the x's that work. And they work for all real numbers. So there's no hole in this one. So again, there's some playoff between these examples, and that'll come up in some of the examples we do. Okay, so again, I'll emphasize this, and we'll talk about it carefully. But this is the game we're playing. Okay. Now here's one that we all think we know, but this is going to tie up, in particular, to some of the ideas we're going to do later in the course with logs. So I want to bring this up, just kind of foreshadowing, right? Because this is going to have similar handled similarly to how we do logs later. So, okay, I'm going to take my time function. Now again, they only gave me the rule, but I'm noticing in particular that this rule is only valid for non-negative real numbers, right? I'm not going to, if I put negatives in complex, we don't even want to go down there, right? So non-negative, greater than 0, positive, and equal to 0, non-negative. Those are the only x's I can plug into that box. Turn it into an equation. But the problem is this equation, y equals square root of x, isn't helpful. How do you compute that? Again, if we had logs, how do you compute that? The issue is you know how to do it because you memorize tables. But what that rule really says, right, how you really calculate this is the rule. The yellow box is really the rule for the square root function. Really, it really is. So I have to have x greater than 0, and I have to take one y value for my function, right? Now let's see how that works. I need a solution set if I'm going to graph, and this is, again, this is going to come up later. X, y, and you plug in the x's. You just jump in with both feet. How do you calculate the y's from that? I mean, how do you calculate a y value equal to square root of x, or y squared equals x? I mean, it's backwards, right? I mean, how do you calculate that? Well, 0, if x is 0, y is 0. If x is 1, y is 1. If x is 2, you can guess y is 4. But what do you have, like 3 halves and others? How do you do that? All right, I need x's are greater than 0. So I didn't make a good choice. I didn't make a good choice of x's. But again, think a minute. What goes in the solution set? All I need the solution set is xy ordered pairs, right? Xy pairs that I can plug into this red equation, right? So for every x that's greater than or equal to 0, I get one y, right? That's a function. Why plug the x's in? Plug the y's in. Plug the y's in. The y's are easy. If I plug the y's in, then it's okay. Remember, I can only have one y value. It's a function, right? So I'll come back to that. I'm going to take these. And notice, I'll just work the other way. I just need xy pairs. How you get them other than cheating is your business. I mean, do math, pray to your God. I don't know. How you get them is your business. Okay? So I'm going to plug in the y value, and I'll get the x value out of that. I mean, it's easy. Again, the idea we're going to be pursuing is fight smarter, not harder. We're not going to try to sometimes in the course we have to do calculations, mainly when we do matrices and linear algebra. Okay, that's down the road. Most of this stuff should be doable, right? So that's my xy values. That goes in my solution set. Again, I only have 5. If I have a set, I can graph it. I'm going to do the next page, and there's my data. And there it is, right? That's the graph of that function. But notice I had converted the function into an equation, and then I had to understand what the equation means, what a square root means. Okay, so you should be able, if you do this section, what should you come out of this doing? You should be able to graph a function by plotting points from the solution set. Now, this is not an ideal scenario, plotting 5 points or 7 points, or even many with your calculator. So what we're going to do in subsequent sections is this is valid for any function. We're going to look at special cases so we can get a handle on this. But at the moment, you should be able to plot points, make a solution set, plot points, and graph the solution set. Okay, that's the main thing out of here. It's a pretty focused section. All right, well, good luck with that.